Hello, everyone. My name is Mark Garcia, and I will be presenting Legis Compare AI, revolutionizing legislative analysis. So, what is the problem at hand? Document revisions are long, expensive, and hard to track. Oftentimes, bills in government go through several revisions, and through these revisions, wording can be changed. And these changes can be quite subtle, but they're very serious. For example, a word being changed from shall to may can change very legal obligations. Another issue is that bill processing and reviews take 50 to 200 hours to manually review changes from versions, but with this tool, we're able to cut down this revision time to seconds. It's hard to track. So through each change, it's actually difficult to see line by line, kind of like how you would see on GitHub, a piece of literature being changed over time. But with this tool, we're able to use AI to show line by line where changes are actually made. And bias, we're able to just give a flat, neutral summary of what's going on and give unbiased predictions on the future based on the context of the situation. So, what do we actually do? Legis Compare uses AI to transform legislative analysis with AI-driven reports. So, first thing you'll get is an executive summary. So, you'll get a high-level overall review of critical changes. Then we'll see the stakeholder impact. So, we'll see who's benefiting from this change and who is being harmed. We'll also see potential outcomes for the short, medium, and long term. And we'll even see evidence on changes being made throughout the entire document. So here's the architecture. So when you go to the homepage, you'll be presented to the landing page, and you'll take the call to action navigation, and you'll be presented a button. And that button is the crux of this entire project. The user will then upload two different documents, so the first version and the second version, and the backend, which is in Fast API, will then use a OpenAI LLM to parse and analyze both documents. But before we actually determine what words are inside here, we're going to do a OCR text extraction. We're going to use that OCR text extraction, and then we're going to use our LLM to process keywords, and then to process our executive summary, our stakeholder analysis, and impact forecasts. And then we're going to do vector embedding on both documents to eventually be able to create some type of output using our RAG model. So to prevent hallucinations from just simply like copying and pasting a document into ChatGPT is that sometimes it might make up things or it doesn't necessarily compare two items directly. So how can we do that safely using AI? We use the RAG architecture. So by doing that, we're able to use search on the documents before we create our generation of the natural language processing. So for example, we'll see the forecast of the impact from these changes, and then we'll see the actual statistics that are being changed, maybe like a financial funding for a specific project. So then all this output is created into JSON, and then it's sent back to our front end, which is in Next.js and Tailwind. So let's take a look at that. So here's our front end. So we're able to change detection, stakeholder analysis, impact forecasting, executive summaries, it's evidence-based, and it's bias detection. So anyone who's doing any kind of document revisions, specifically in government, this would be fantastic. So let's do a quick dive. So we go in to the application, and it's very simple right now. So you can just upload your documents, and then we're going to hit analyze. And this is not in demo mode. This is fully working MVP. So our Next.js is going to make a REST API call to our backend, our Fast API endpoint, which has all the OCR and LLM processing. And then once that is done processing, it's going to be sent back into the front end. So something we could do going forward is maybe we could do more parallelization, so we can have multiple threads running at the same time. So the reason why this loading state is so long is because there's so much content being generated. So great. We have a comparison has been made between document 1.2 and 1.3. So the revised document proposes significant enhancements in funding across technologies, teacher support, and accountability measures, which lead to improvement in educational outcomes for a broader range of students. So I'm going to quickly go over some of the key insights. So in version 1, we can quickly see that we have 1.5 billion to 6 billion over the next 5 years, and this would be over the next 6 years, right? It's very clear to see without even reading the document. We know it's being changed. Same thing here for the grade of the students, as well as what they'll actually be receiving, right? So provided with a free laptop, and then receive personal learning devices. So it's very different. So let's dive into, right, here are other changes, and these are all cited. And we'll go back and look at that official document. But here's some analysis. So let's look at the impact of this. So the demographics of the students in undeserved communities, positive impact, right? So this is great. Institution, the teachers get a little bit of a cutback, as well as the district. Although it's more on the positive side, it's still mixed, right? So it's questionable. So then we see increased funding will lead to better resources and support for schools. Technology access will improve student engagement and learning outcomes. Enhanced accountability will ensure proper funds of use. And then we have a short-term, medium-term, and long-term analysis. So initial increase in funding will boost local economies through school job creation, social immediate improvements in technology access for students, particularly in undeserved areas, and then support for increased funding and accountability measures for politician bipartisan. So great. So I'm just going to hop back. So just to recap on how this project was made, it was made in Next.js, React as the underlying foundation, and Tailwind for styling. Our backend was written in Python. We used Fast API. We were able to use the OpenAI GPT-4 API using 4.0 Mini, and we implemented the RAG architecture for retrieval augmented generation. And we were able to optimize for performance, accuracy, and security. So going forward, we would want to create a transparent governance powered by AI. So I would love to seek mentorship or any type of partnership if you think this project may be interesting. And we would happy to be empowering staffers, journalists, and citizens. And here's a link to the code. Thank you so much. One last thing. Here are the documents. And you can also find these inside the GitHub as well, if you want to see how well the AI performed in the demonstration. Thank you.